Mercury, the closest planet to the Sun, a scorching wasteland. Ever wondered why we've sent rovers to Mars but not Mercury? Let's dive into the facts. Imagine a place where the sun blazes hundreds of times brighter than what we experience on Earth, where temperatures swing between unimaginable extremes, and where the very ground beneath your feet could spell disaster. This is Mercury, a planet of stark beauty and unforgiving challenges. In this video, we'll explore the daunting obstacles that make Mercury one of the most difficult places to visit in our solar system. From its extreme environment to the gravitational tug-of-war it endures, we'll uncover why reaching this small rocky world is a cosmic challenge for even our most advanced spacecraft. Let's talk extremes. On Mercury, a day at the beach means enduring temperatures hot enough to melt lead. That's over 800 degrees Fahrenheit, folks. But wait, it gets even more extreme. Because Mercury has virtually no atmosphere to speak of, there's no blanket to trap heat. So, as the sun sets on this desolate world, temperatures plummet to a frigid minus 290 degrees Fahrenheit. That's a swing of over 1,000 degrees Fahrenheit, the most extreme temperature variation in our entire solar system. And if the heat wasn't enough, imagine being bombarded by intense radiation from the sun, a constant barrage of energy that would fry our electronics and prove lethal to any human foolish enough to step foot on the surface without heavy-duty protection. This lack of atmosphere also means no protection from meteoroids, those cosmic bullets that constantly whiz through space. On Earth, our atmosphere acts like a shield, burning up most meteoroids before they can reach the surface. But on Mercury, it's open season for these celestial projectiles, leaving its surface pockmarked and scarred. This extreme environment makes designing a spacecraft to withstand these conditions incredibly difficult. It's like building a suit of armor that can simultaneously withstand a blast furnace and a cryogenic chamber while being light enough to launch into space. But the challenges of visiting Mercury don't stop at its surface. Journey to this scorching world is just as daunting. Imagine flying towards the sun, its heat intensifying with every passing kilometer. That's the challenge of reaching Mercury, and it's not for the faint of heart. The sun's immense gravity constantly tugs at spacecraft, threatening to pull them into its fiery embrace. Navigating this gravitational well requires precise calculations and course corrections, pushing the limits of our engineering capabilities. Even if we manage to design a spacecraft that can survive the journey and withstand Mercury's brutal conditions, landing on this alien world presents another set of hurdles. Without an atmosphere to provide drag, spacecraft can't rely on parachutes for a gentle descent. Instead, they need powerful thrusters to slow down and execute a soft landing, all while battling the sun's relentless pull. So, while Mercury might seem like just another rocky planet at first glance, its extreme environment makes it a formidable challenge for exploration. We've talked about the heat, the radiation, the lack of atmosphere, but Mercury has another trick up its sleeve: gravity. Now, you might think Mercury is a small planet, so weak gravity, right? Well, yes and no. While it's true that Mercury's gravity is much weaker than Earth's, about 38% to be precise, it's the sun's gravity that throws a wrench into the works. Imagine trying to park your car on a steep hill, except the hill is the sun's gravity, constantly trying to pull you in. That's the challenge spacecraft face when approaching Mercury. To get into orbit around Mercury, you have to slow down considerably, almost like applying the brakes while going downhill. This requires a lot of fuel, which adds weight to the spacecraft, making the journey even more challenging. And landing, that's a whole other ball game. With the sun's gravity constantly tugging at the spacecraft, landing on Mercury becomes a delicate dance of thrusters and trajectory adjustments. One wrong move and you risk crashing into the surface, or even worse, being flung out into the vast emptiness of space. NASA's Messenger probe, the first spacecraft, spent over 6.5 years traveling through the inner solar system, using multiple flybys of Earth, Venus, and even Mercury itself to manage its speed and trajectory before finally settling into orbit around the planet. This intricate dance of gravitational assists highlights the incredible precision and planning required to reach and orbit this tiny, sun-baked world. It's not as simple as pointing your rocket and hitting the gas. We've touched upon the challenges of reaching Mercury, but let's delve deeper into the specifics. Imagine this: you're not just flying towards a planet, you're flying towards a furnace. The closer you get to the sun, the more intense the heat becomes. This means spacecraft need special heat shields to protect their delicate instruments from frying. These shields have to be incredibly robust, able to withstand temperatures that would make even the most heat-resistant materials on Earth crumble. But it's not just about building a spacecraft that can take the heat. It's about navigating the intricate cosmic ballet of gravity and momentum. Remember those gravitational assists I mentioned earlier? They're not just convenient shortcuts, they're essential for reaching Mercury. To escape Earth's gravity and set course for Mercury, spacecraft need to be launched at incredibly high speeds. But arriving at Mercury with that same velocity would be disastrous. You'd simply slingshot around the planet and be flung back out into deep space. That's where gravitational assists come in. By carefully plotting a course that uses the gravitational pull of other planets, spacecraft can gain or lose speed without expending precious fuel. Think of it like a cosmic game of billiards, using the gravity of planets like Venus and even Earth itself to adjust the spacecraft's trajectory and speed, eventually guiding it towards its target, Mercury. The journey to Mercury is a testament to human ingenuity, a delicate dance of physics and engineering. It requires meticulous planning, precise calculations, and a deep understanding of the laws that govern our universe. We often take our atmosphere for granted, but it's a crucial element that makes Earth habitable. It provides us with the air we breathe, protects us from harmful radiation, and even helps regulate our planet's temperature. Mercury, unfortunately, wasn't so lucky. This lack of atmosphere exacerbates the challenges we've already discussed. Remember those meteoroids without an atmosphere to act as a shield, constantly bombarded by these cosmic projectiles, leaving its surface scarred and cratered. Imagine living in a world where you constantly have to be on the lookout for falling space rocks. Not exactly a recipe for a relaxing retirement, is it? The absence of an atmosphere also means no atmospheric drag, which, as we discussed earlier, makes landing on Mercury incredibly tricky. Spacecraft can't rely on parachutes to slow their descent, making pinpoint landings a nail-biting feat of engineering. But perhaps the most significant consequence of Mercury's lack of atmosphere is its inability to retain heat. Remember those extreme temperature swings? Without an atmosphere to trap heat, Mercury's surface experiences scorching days and frigid nights, making it a less than ideal location for a vacation home. This lack of atmosphere also means no weather patterns, no wind, no rain, no clouds, just a stark, silent landscape bathed in the harsh glare of the sun. While this might sound appealing to those who prefer their planets on the quiet side, it also means no erosion, no geological activity, no dynamic forces shaping the surface. Mercury is a world frozen in time, its ancient surface a testament to billions of years of cosmic bombardment. So, we've established that Mercury is a tough nut to crack. But why bother? Why go through all this trouble to visit a planet that seems determined to thwart our every effort? It's a fair question. After all, we have Mars, our planetary next-door neighbor, which seems positively hospitable compared to Mercury. Mars has a thin atmosphere, evidence of past water, and even the potential for terraforming in the distant future. So, why not focus all our efforts on the red planet? Well, Mercury has its own allure. For starters, it's a scientific goldmine. Studying Mercury can provide valuable insights into the formation of our solar system, the dynamics of planetary interiors, and the effects of solar radiation on planetary bodies. Mercury also harbors potential resources such as rare Earth elements, which are becoming increasingly important for our technological advancements here on Earth. However, the cost of extracting these resources and transporting them back to Earth would be astronomical, literally, and that's the crux of the issue. Cost versus reward. While Mercury holds scientific and potentially economic value, the challenges and risks associated with reaching and exploring this planet are immense. The technology required to overcome these challenges is still under development, and the cost of such missions would be substantial. Compared to Mars, which offers a more realistic target for human exploration and potential colonization in the future, Mercury's harsh environment and logistical challenges make it a less appealing candidate for long-term missions. So while we continue to unravel the mysteries of this enigmatic world through robotic missions like Bepi Colombo, it's safe to say that Mercury will remain a challenging and unforgiving destination for the foreseeable future. Mercury might be small, but it's a beast to visit. From killer temperatures to sun's gravity trap, it's a no-go zone for humans, for now. So next time you feel Earth's summer heat, just be thankful we're not on Mercury. While we continue to explore our cosmic backyard, pushing the boundaries of human ingenuity and daring, some destinations remind us just how precious and fragile our own planet truly is. Mercury stands as a stark reminder of the challenges and rewards that await us as we venture further into the cosmos, and a testament to the incredible resilience of life on our own pale blue dot.